Hi and welcome. In this short video, I would like to present you some basic configuration of OSPF protocol, and in the end, I prepared for you bonus topic. I have hope that this presentation would be clarity and not boring. Let's begin. Firstly, we should configure contiguous area 0 and area 30. We all see that router 8 has every single route in his routing table for all over the network, but router 12 has only routes to R8 and his own network 172.16.10. Okay, let's repair that issue. Open R8 terminal, type router OSPF1, area 10, because this is a transit area to area 0. Virtual link 2.2.2.2. This is a R2 LSID RID. That RID do not must be a reachable address. Then switch to router 2 and do the same things but point to router 8 ID. What we will see that two routers become full neighbors through OSPF VL1 interface. Next, we check the R12 routing table. Of course, the table should be larger than before because R12 learned routes from area 0. The same things we should do to connect two discontiguous areas 0. Now we prepare to redistribute routes from EIGRP to OSPF and filter it with route map. Okay, in router 5 routing table we see all 10.16 networks. Let's create a standard access list that would be perform a filter for our networks. I prefer to deny 10.16.3.2.24/27 and 10.16.32.0/19 networks. For that case, we should use a wildcard mask. Do not forget at permit any state at the end of access list. Then we create a route map named to OSPF with permit state sequence 10. Next, matching the IP addresses with created earlier access list. Now we go to the router OSPF1 and redistribute from EIGRP 100, filtering with route map to OSPF. Don't forget about submit command and metric. Now we can see that our filtering process ran successfully. In some cases, the routing table is too large and router must process much more data, which consume CPU time and memory space. For this issue, we use, for example, STAP and NSSA area. We will configure NSSA in R3 with default information originate. Do not forget to enable NSSA in others routers in this area. If you do not configure that commands, the router do not establish the agency. Now, in the routing table, we have default gateway and few networks which were redistributed. Okay, let's begin bonus part. On routers R1, R2, R3 and R4, we have configured MPLS feature with traffic engineering. We use traffic engineering to allocate resources for creating tunnels with allowed for us traffic managing. Simply enable MPLS on R2 and add traffic engineering tunnels feature. Go to the router OSPF configuration mode. Announce traffic engineering router ID in area 0. Next, go to the every interface with participate in MPLS traffic engineering. Activate traffic engineering and reserve bandwidth for which RSVP. Then create interface tunnel and add destination address. Change mode to MPLS traffic engineering. Bind interface that should be announced. Announce the tunnel with RSVP. Reserve the bandwidth with that tunnel. The bandwidth must be equal or less than configured before. Give the priority to the tunnel and create paths. I created one static and one dynamic for protection. Now include next hops in static paths. We see that tunnel is up and working. The dynamic path is first because we add next hops after creating tunnel. I'd like to thank you for viewing.